Okay, so now we will do our get minimum method. Minimum and finding maximum in our IntTree class is very simple because our tree is already sorted. So where you can find the minimum value in your tree, where it means it will be on the left side of your tree. So it means you're saving your time by splitting your tree into, like, you don't have to check rest of the right side of your tree, because you know that all the higher value of the root is on the right side. So you are saving time with searching your minimum number and maximum number in your tree. How to write the minimum method? Again, we will start with public and private. Public, and as we are returning our int, it will be int get minimum method. Get minimum. Are we asking anything from user? Nope. Starting curly braces and ending curly braces. And what we do in our public method, we call our private method name as get minimum, and we will pass overall root. So what if your tree is null? You can test this condition in your public method so that you don't have to take this call to your private method if the tree is already null. So you can check in your public method that if overall root is null, overall root equals to null. If this is the case, then you can just throw new no such element exception in this. No such, all the letters are capital, such, first letter of every word is capital. Exception, open close parentheses and semicolon, and starting curly braces, closing curly braces. If overall root equals to null, then no such element exception, close this curly braces, and then as this is a return type, we have to return this get minimum, whatever the overall root has given us the value. Now we will create our private method, private, and what we are returning, same, we are returning an integer, and we'll say get minimum is the method name, and what we are accepting is overall root, which is the data type is IntTree node. For that, IntTree node root, starting curly braces and ending curly braces. As we have already tested, you are inside of this private method. It means that your overall root equals to it's not null. It means you have something. So it means we will go in our directly how to check. Now get minimum, this is your tree. It means your tree is not null. That's why you are inside of this private method. How to run your loop to find the minimum method or minimum number. What you will write. How you identify. It's obvious that you are doing recursion, right? You're doing recursion, and in recursion there are two rules. There are base case and recursive case. What will be your base case? When you will stop? How to identify your base case and recursive case? Where your minimum number will be? How long you have to run the code? Your minimum will be on the left of your root. So if your root has no left, if your root has your root left is null, it means this is the minimum number. If your root is not, if your root left, as this is your root, right? This is your root, you have to go all the way to the left to find the minimum number. So you will check if your root has a left. Yes, it means there is another minimum number in the tree. So make this your root. Then this will becomes root. You will check, is your root dot left is null? You say yes, the root dot left is not null. It means there is another minimum number. When you have checked root dot left, is it null? It means yes, this is null. It means this is the minimum number. So return root dot data. So that's how you will identify the base case and the recursive case. So your base case is if root dot left is equals to null, which will stop your code, that it's null, there is no more looping in the tree. If it's null, then it means return root dot data, that is you have found the minimum number in your tree. Else is the case, it means your root dot left is not null, maybe you're at 8 or maybe you're at 5. So else is the case where you will run your loop, and how you run your loop, you write the recursion, which is how you write recursion, you write get minimum. you write the method name, which is get minimum, and parenthesis, and how you are updating your root. You are updating it to the left side. So you will write root dot left every time. And that's, you will use, as this is returning something, so you will use the return keyword to make that call. Return get minimum root dot left. Every time it will go to the left side, left side, left side. And as you find root dot left is equals to null, which is, for example, at this root dot left is null, then return root dot data. 3 is the minimum in this whole tree, right? Any questions? As you can see, there is an error because no such element. All the exceptions are exist in your java.util package. So don't forget to import java.util. And let's go to our client class. And as you can see, this is your tree 85311. If I call the minimum method, so we are returning something and we are printing something in your minimum. So how you will print the minimum, you will write in system.out.println, and you will say minimum number in tree is colon and concatenation, concatenation, and call the method name, which is t dot get minimum, and it will print the minimum number from your tree. The drawback of using this loop and taking values from user is we have to re-enter all the values. So let's run our code. And 0 to quit, let's make the same 8, 11, 5. You can try different values. I'm just using the same values because we have the tree here. So the minimum in tree is 3. As you can see, you can put new line before \n here as well, so that it prints to a new line. Okay, that's it.